Hello. We are going to delve into two new topics here, which are going to be pretty important, I think, in general for C++ programming, which are command line arguments and Makefile. These are kind of related in a way in that Makefile will rely on you being able to provide command line arguments, and both of these are really necessary for you to avoid having to constantly press up, 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 find the previous command, hit enter, up again, get the previous command. Instead, we have a little cleaner way to do this with Makefiles, although you do have to put the effort into making them. So to get started, let's look at exercise 1. Make a program that takes a simple molecule as a command line argument, like H2O, and outputs the number of atoms of each element in the molecule. So for instance, if I have my program called molecule counter, and I pass it as a command line argument, h-2-o-1, meaning H2O, it should output H:2, O:1 with a comma in between. So let's see if we can get this going. Let's make a new file. This is exercise 1. Okay, and here's what we have to do. There's definitely going to be a number of different ways to approach this problem. I'm kind of just going to go at it and we'll see exactly where things take me. I am going to definitely include IOStream to save myself some headaches. I'll use namespace std. And now I think for this one, because we're just kind of dealing with some strings here, and I think it should be easy enough, I'm not going to really do too much else. I'm not going to do more than really necessary. Maybe some of the later exercises will have me expand on this a bit. But for now, I actually need to pause because up to this point, every time I've written int main, I haven't given it any parameters. It turns out main can have parameters, and there's two specific ones that it's often looking for. One of them is called argc. This is the argument count. How many things have been actually passed in to run this program? And the second is a character pointer, argv, array. You can also do a double character pointer array if you want. And what this is it's an array of strings, basically, where each one is the actual values that you're entering, the strings that you're typing after the executable. So my executable is called molecule counter, and I have an argument vector, is basically what this is, that includes h-2-o-1. Now, for what's going on here, first of all, I want to make sure they actually put in a molecule. If they don't, this whole thing kind of goes kaput. So I'm going to double check and see if argc is less than 2, then output usage argv0 space molecule. And just pause this for now. And I want to run this to make sure I didn't mess it up, and assuming I didn't, then we will, and this is a molecule counter. Yeah. Okay, so let's take a look at what's going on here. When I output a string from this program, let's look at what it outputs. It outputs the word usage, because I said so. It outputs /molecule counter, and it outputs molecule. And in here, well, here's the line that prints that out. So argv0 is molecule counter. And that's because when you run a program from the command line, every single thing you type in is one of the arguments. So the first one is actually the name of the executable with a / in front of it. Now, I want there to be at least 2. I want there to be the executable, but I also want there to be some kind of molecule. If there's fewer than 2, that means they obviously haven't typed it in. In fact, in this case, I actually want them to have exactly 2, because if they type in any more, my program's not really going to know how to handle it. So now if I am at the point, and here I'll also return 0 because obviously this didn't work. Okay, so now I can assume that there are 2 arguments to deal with. One of them I can kind of ignore. I don't really care about the name of the executable. What I do care about is the thing they typed in, the H2O1. So here I have a string, and what I want to do is I want to kind of go through each character and figure out if it is a capital letter, in which case it indicates that it is the name of an atom. Sometimes that could be followed by a second letter. If you think of, for instance, helium is He, so I need to make sure that I'm counting for that. And then if I see a number, that's associated with the how many there are. So what I'm going to do is I want to go through every character of this string. So I think we'll do a for loop. I is 0, I is less than the length of my string. My string is the first, I guess the second element of argv. And since it's a string, I'm going to use its length. Okay, and now I'm going through each character one at a time. So, now, if I have run into a capital, that means that this is a new, and I think for now we're kind of just gonna assume that they typed this incorrectly. If they type in like the wrong format, we don't really know how to handle that at the moment. So right now I'm just gonna assume they've done everything properly. So I'm going to need to have a string to represent the current atom. And I'm also going to need to have an integer. I guess a string is fine too, it doesn't really matter. To represent the current atom count, which is how many of the atom are there. I'm also going to make a bit of an assumption here and assume that if we're talking about simple molecules, you're probably not going to have 20 or 10 even of any individual atom. So we'll assume these are all single digits. Again, if it's not, it just means you have to kind of work around that situation. But we're going to keep this simple and assume everything looks like letters, dashes, and numbers. So, okay. If the so argv1 is our current string. So if, and I think it's going to be annoying to refer to this as argv1 all the time, so instead I'm going to do actually is string molecule is argv1. And now I can just write molecule instead. It's a little more understandable when I'm reading through the code and thinking about what's happening. So, okay, I got my molecule. For each letter in the molecule, if it's an uppercase letter, then I need to think for a second about my current atom. So that means that my current atom is going to be this. So let's say the first thing I find is a capital H, right? Okay, well clearly the current atom then should be H. Now it's also possible that the next letter is a lowercase letter, for instance Mg for magnesium or anything like that. So I do need to consider that as well. If is lower molecule I plus 1, and this is the scenario where it's immediately followed not by a dash, but instead by a lowercase letter, I should add that to my current atom. Plus equals molecule I plus 1. Okay, so all of this, oops, is for getting the current atom. Otherwise, there's a possibility that if it's not an uppercase, that it is a number. Now, here's the question, is how do I figure out if it is a number? I can do this the tedious way, which is to just compare to all of the possibilities, 0 to 9. There might be a C++ thing that helps me. Yeah, so here's what I can do. Okay, the current, if the current character is between 0 to 9, then what I can do is I can say if the letter, the symbol, subtract 0 is greater than or equal to 0, and less than or equal to 9. So what on earth is happening here? If you think about these as ASCII values, right, this is some, let's assume it is a number, right? Say it's 5. When I take the ASCII value of 5 and I subtract the ASCII value of 0, I'm actually left with the number 5 because it's exactly 5 spaces in the ASCII table further. Which means that 0 all the way up till 9 will be bigger than 0 if I do this subtraction. Anything on the that has too low of an ASCII value will be discounted. It won't be included. And on the other side, I want to make sure that it's between 0 and 9, so I need to make sure it is potentially less than or equal to 9 as well. If that's the case, this means I have found a number. So this means that the current atom count is this, and I can output the current atom followed by a colon and a space followed by the current atom count followed by a comma. Now, I do need to consider that I don't really want the last one to have a comma after it, and it's a little annoying to deal with that situation, but I guess I'll have to. And I think what I'm going to do is see if it is the first time, or how should I do this? So actually what I'll do is, if this is the very first symbol I find, I won't print a comma. But if it is the second or further, I will put the comma first. So to do that, I need to say a Boolean, which is first atom is true. And then over here, if is first atom, or actually if it's not the first atom, then I will if it is the first atom, then we'll say is first atom becomes false. Otherwise, I will print a comma space. I think this should work. And this will ignore all of the dashes because those actually don't really matter. And then this is all for get the atom count and print all at once. As soon as I've found exactly how many atoms there are, I can just stop and print it. So if that's the case, then it will modify this Boolean to make sure that I no longer thinking it's the first atom. And if it isn't the first atom, I print a comma first, then I print the atom name, then a colon, then how many there are, full stop. And I think before my program is over, I'll just output a new line so that I'm spacing it nicely. Did I make a mistake? Let's see. No, it doesn't sound like it. Okay, so what if I do H2O1? Okay, something is wrong. It did not get the numbers, which is a problem. So I need to figure out why that is. So it's supposed to print the atom count, but the atom count is not being calculated correctly. Let's see what the... because it is figuring out that there are numbers, because it does print H colon something, and O colon something, but it's not actually printing values. So... Oh, I see. I made the atom count a string, but it's actually just a an integer. There we go. Very easy fix. Yeah, because I want to know how many there are. You probably could do this with a string instead, but I think it's fine to just make it an integer. I suppose if you use a string, you don't have to do any of this weird kind of addition stuff, which I was doing from the thought process of it being a integer. But that's okay. This works totally fine. So let's kind of walk back through everything and talk about what we've done. The first is to check for it's actually they've inputted a molecule. If they put in a molecule or they put in a bunch of other stuff, this isn't quite right. Now, if they do it properly, that means the first element of argv at index 0 is the executable name, and the second at index 1 is the actual molecule. I'm going to go through and grab every atom. I need to know how many there are, and I also need to keep track of whether or not it's the first one, because if it's the first one, I don't really want to print a comma right away. I only want to print a comma if there are, if I'm on the second one or more. For each letter in my molecule, if the letter I'm at is a capital letter, that means I'm on a new atom. So I need to say that, okay, this is the current atom. And I also need to consider that a atom may have 2 letters in it, in which case I need to make sure I add that. In fact, I should check that right now. Can I do H to MG1? Is that okay? Yeah, that should be fine. But probably this will mess up if I do like this. Yeah, it like doesn't quite work. It won't catch the H. But this isn't valid anyway, so it's fine. Okay. Now, if I am not on an uppercase letter, then I want to see, is it a number? So this is all, is it a number? If it is a number, then I want to figure out what the number is, and then I'm going to print. So this is all print. If I'm on the first atom, okay, great, and I'm no longer on the first atom. Otherwise, I want to print the comma. So when I print the first H2, great, I just print H2. But once I'm on anything after that, I want to print a comma first, and then other stuff. So again, kind of just to show how this looks with something longer, let's say H2S1O4. Now it's going to give me H2 comma, and then comma S1, comma O4. And every time I add another one, I add another comma. Then I print out the atom with a colon and a space and how many there are, and I'm done. Okay, so that's our first little introduction of some arguments. And let's move on from here. Okay. Modify the program from exercise 1 to support a -s flag, which when used will allow the user to input a simple format for the molecule that looks like the following, where here it's not separated by dashes and doesn't say 1. It just has nothing, if that's the case. Okay, so let's grab this. That means we'll have to make some changes, but we've already done a lot of the work. We just have to consider some new possibilities. So first of all, here's my problem. Okay. So now it's possible that I have more than 2 arguments. So first of all, if there are less than 2, I know I've bundled it, right? Now, the second possibility is I need to see, is there a S flag in the second spot? So if argv1 is -s, then I'm on simple mode, and I'm going to have to handle that. Otherwise, I will do the way I do stuff before. All this can get tabbed over. So one option is simple mode, and the other option is the way that we did it before. Now, if we're on simple mode, what do we have to consider? Well, first of all, the molecule is no longer in position 1. It's now in position 2. I still want the string current atom and the item count, and whether or not it's the first atom. Since I'm going to have these no matter what, I'm actually just going to put them above, because I always want to know that these are a thing, whichever way I do it. Okay, now I am going to go through the molecule, but I'm not going to do it the same way in both scenarios. So I still do want this. Whoops. However, and again, I kind of want to do the same idea where I'm checking to see is it an uppercase letter or is it a number, but here's the thing. If I find an uppercase letter and I then find another uppercase letter, I actually need to assume that the current atom count is 1. So I'm actually going to default to saying the current atom count is 1. And here's what we'll do. We're going to start out with a Boolean which is, actually, here's what we'll do. We'll use the fact that the current atom starts as an empty string. And if the current atom is an empty string and I find an uppercase letter, great, that means this is the atom we're on. If the current atom is not an empty string and I find an uppercase letter, that means I actually know I have to print out first. So here's what we'll do. If is upper, so same thing as here, but we'll add another part of this condition. So if it's an uppercase and current atom is an empty string, then I will do all this stuff. Sure. Same as before. So this is new atom. Otherwise, if it is an uppercase, but I haven't run into a number yet, that means I need to actually print. So I'm going to copy the printing code. And this means that I ran into a scenario where it's something like NaCl, where there are no numbers here, but I ran into a second uppercase letter and my current atom is Na. Now, one important thing I have to do to make sure this works is after I've printed out the current atom, I need to reset it back to being an empty string. So that means I've printed now the atom I've run into. Or actually, no, it's not going to be it's not going to be an empty string. It's going to be this. So I print out the one that I have, and then just thinking through this for a second. Okay, so actually the only scenario where this really happens is the very first one that I run into. Because if I start at the very beginning, the very first character is a upper letter, which I guess it will be. I can maybe shorten this code. Because I know that they're always going to start as with a capital letter at the very beginning, because they all start with a capital letter. So maybe what I'll actually do is I'm going to start with the current atom being whatever the first. Do I want to do that? Sure. No, actually I don't want to do that. It will mess up my code from down below. Let's do this. If the very first letter I run into is uppercase, which I sure hope it is, then I'll grab that first atom. Great. Otherwise, if I run into an uppercase letter, yeah, because this also might happen if I do run into a number. If I run into a number, then I want to remove the current atom. So here's what we'll do. We'll actually have our second else if be this thing down here, which is get the atom count and print. Yeah. So if it's not an uppercase letter, then check to see if it's a number. If it's a number, okay, it's time to print. Grab the atom count. If it's the first atom, it is no longer, and print it. Okay. If it's not a number, if it is an uppercase, if it's a lowercase letter, we don't really care because we already grabbed that when we grabbed the atom. So we're handling this situation where it's a lowercase letter. We're handling the situation where it's a number, which is what this is. Now, if it's an uppercase letter and it's the very first one, or it immediately followed a number, and that means I need to write this code here. Current atom equals this. I've just printed one out. I don't have any more atoms left. If I'm over here, this means that I have an atom, like Na, and I just encountered the C in Cl. And what I should do is print out Na, that there's one of them. So that means that I also need to reset the current atom count to be 1 down here. Reset atom stats. So we have the new atom scenario. We have the found count. Then you get it and print it. And then here is encountered new atom but no number defaults to one atom of that type. So if I have Na and I run into the C and Cl, that means I have one Na to print. And in that case, I will print out the atom count, which will be 1. And the current atom will become the one I just ran into, Cl. Okay, so I think this should work. Let's try it out and see what happens. So we're going to compile exercise 2 into molecule counter. And we'll pass it NaCl4. Oh, okay, it's unhappy. What did I mess up? Oh, I forgot the S, the -S, NaCl4. Okay, now it printed nothing, so I got some things to fix. Okay, so first of all, this should be a less than 2, not less than equal to. I'm not quite sure why I did that. Okay. Okay, let's see what happens now. Okay, still not printing anything, so that's kind of odd. So what we're going to do is try to figure out where a mistake has happened. So the molecule should be, let's see if it is checking every letter. So I'm just going to output molecule I, just to see. Okay, so it's not even grabbing the molecule, which is an unfortunate scenario. What if I put single quotes here? Is that sufficient? No, it's not quite happy with that. Okay. Let's see if it does grab the molecule at least. It's not even grabbing the molecule, so there's something wrong here. Let's output all the arguments and see what happens. I is 0, I is less than arg C, I++. Output arg V, I, new line. So we got molecule counter, -S, and NaCl4. So it is finding all of the, it does have all the things there. Now, I'm thinking this isn't working possibly. Is that right? Arg V is arg V1 equal to S, then S flag found, otherwise S flag not found. I'm just doing some debugging here to see if I can figure out what's happening. So it doesn't find the S flag, which means I think that this comparison isn't quite working. So I wonder why it's not being detected. And arg V1 is -S, right? It seems to think so. -S, okay. is argv1 0 the hyphen? Hyphen. So it can do that. It just seems to have some trouble detecting this. And if I do single characters, does that help? Or single quotes? Okay, then it's unhappy about me doing this. There are some ways, like, so one option that I can do is I can literally compare the dash and the S and make sure it's exactly equal. I feel like there's a cleaner way to do this. What if I make it a string? What if I say flag equals argv1, equals, sorry, S. Flag. Okay. I think the issue here has to do with the fact that my argument vector contains not string objects, but just sequences of characters, and it's not able to compare properly the string with the character sequence. So to fix this, I'm going to just make a string variable called sFlag, and it's the dash S, and and then I'll fix my code down below. So instead of comparing it to S, I'll compare it to sFlag. And this, I think, should fix it. Where was my attempt? Here. There we go. Okay. It's kind of an annoying thing, but this just has to do with the fact that C treats what's called C strings and just strings in different ways. So to deal with that kind of nonsense, I'm just going to make a string variable. I'm going to compare my command line argument to the string variable as opposed to comparing it to quotes dash S, because that doesn't seem to really work. And this time I actually found the dash S flag. And then if I don't include the dash S flag, it should do the normal thing, like NA-1-CL-4, just as before. But it won't work if I forget the dash S flag. It'll be like kind of confused. But that's okay, because it's not supposed to do that. It's only supposed to work with the dash S flag. So you see these kinds of flag things come up all the time in C++, and the reason for it is so that it becomes very convenient if you're just working on the executable side of things to be able to run stuff without having to worry about modifying the code significantly. I did have to write a lot of code for this, unfortunately, but I think that's okay, and maybe we'll be able to reuse this code for the other exercises. But let's move quite along. Okay. Enhance the program to accept multiple simple modules and output the number of atoms of each element in each module. So, okay. I think we kind of know what's going on here, and we're doing this with the simple option, not with the one with the hyphens. So we're just going to worry about that. Okay, so here is my new problem. And now I need to consider, okay, so here I had there was only a single molecule, which was the second character. Now there could be many more. But actually, I don't think the code to fix this is that difficult, because here's what it's going to look like. So right now, my molecule is just the second argument, right? And all this code handles just dealing with that molecule. I just need to make this work for every molecule. So this is actually not that complicated. All I have to do is say, okay, for I equals 2, that'll be the first molecule. I is less than argc, I plus plus. And instead of the second argument, I'm just going to take the ith one. All of this goes inside of my loop. And done. Let's try it. It's always nice when the exercises are actually a lot simpler than you think. Okay, so this is exercise 3. And we're going to pass it NaCl4, H2SO4, MgHe. Why not? Okay, something is wrong. That's because I forgot the dash S. That would help. Let's try that again. Hey, look at that. NaCl4, H2S1O4, Mg. Ooh, we have a mistake, which is if the last one doesn't end with a number, it doesn't print it. So that's the thing that we missed when we were doing exercise 2, because we had a bad example. NaCl4 ended with a number, so it was nice and clean. But we realized that we had a scenario where it didn't end with a number. So here's what we're going to do. We're going to fix that. Right here, if I have gone through the entire module, the molecule, I should say. So when I print out a, so if I've encountered a number, and so keep in mind with simple molecules, you'll never see 1. You're never going to see Na1Cl4. Like that's not valid for the proper format for these things. Which means that if the current atom count is 1 when I am done, that means that I have not encountered a number, and I still have something to print. So I'm actually going to output the current atom with a 1. And I'm going to do that once I've gone through the entire molecule. So if the last character wasn't a number, the 1 atom. And so here is my printing. Just like before, if I still have to consider it could be the first atom. But if it's not, then yeah. Okay, let's try that. There we go. And now this means it actually should work okay with like something like Mg, where just Mg has numbers, but it still should print it out. Okay, great. An easier exercise than I thought it might be, but that's okay. It sort of just has to do with being able to use that argument count to our benefit. And since we know how to do that, the exercise becomes pretty trivial, which is always nice. Okay. All right, moving right along. Exercise 4, modify the program to handle an invalid molecule format gracefully, displaying appropriate error message to the user without crashing. So if we run into this scenario, it should output invalid molecule format. So I think, how many different invalid molecule formats can you think of? There's kind of an infinite number. I think what we'll do is we'll just focus on, first off, not the simple one, but the one with the hyphens. And what we'll do is we'll verify that. And so the reason this one is wrong is because you have a number that was printed right after another number. There's also a lowercase character without an uppercase character. So that seems really odd. So here's what we're going to do. We're going to just modify this so that it has that in exercise 4. There's potentially an infinite number of ways you could put in an invalid one, and I don't think we really have the time to handle every single possibility, but we'll just stick with dealing with a scenario like this one, where either a lowercase letter appears out of nowhere, or a number appears with no letters in front of it, or there's double dashes, something like that. So, okay. Actually, I'll bring this down below to the part where we're working on that, which is down here. Okay, so we've grabbed our molecule. And now this whole code is kind of presumed under this idea that we are getting valid input, but we may not. So the first thing we should probably do is check to see, is the first letter uppercase? If it's not uppercase, we've already hit a snag. But actually, maybe we want to write out all the possibilities. So the potential issues include lowercase letter without preceding uppercase letter. Extra hyphen, extra number, missing number. So let's try to handle these things, and we'll put in a message for each of them. And I think we'll do this by, we'll just throw an error and we won't bother catching it because I don't think it just says it's just going to output this. So we'll just throw an error, and I think that should be fine. Okay, let's start with the first one, lowercase letter without a preceding uppercase letter. One thing we actually could, so there's a couple ways you can approach this. Maybe the cleanest way, and if you like really think through it, probably could be done, is actually going through here to like parse all of the stuff that's in there. But actually what I think I want to do is I want to actually just go through and validate the format of this molecule. So I want to write a function for that. Right now I've done everything in main, which is actually pretty messy. And there's a lot better ways to do this, but I've been kind of just like coding on the fly. But instead what we'll do is we're going to write a function called void validate molecule. And it's going to take a molecule as it, and this will throw an error if the molecule isn't valid. Okay. And then here are some potential issues. Okay, so let's start with lowercase scenario. For I is 0, I less than molecule dot length. Or actually, maybe we'll probably try to handle most of them all in the same go, but we might have to go through it a couple times just to check. Okay, so first time around, is there a lowercase letter that shows up without a preceding uppercase letter? If so, it's in the wrong spot. There is a problem and we immediately need to stop. If molecule I is lowercase and not is upper molecule I minus 1, then we have a problem. So we throw a, what did we say kind of error was it? It was, I think, a runtime error. It didn't really say, so I'm just going to throw a runtime error. It seems fine. What was the error? Invalid molecule format. We'll keep it kind of basic for now. Is this the right syntax is a good question. So let's double check. Is this the right syntax? I missed a parentheses, I think. Oh no, I missed I++. Okay, so it seems like it's okay for now. So there's my runtime error that I'm throwing. And let's validate a molecule. So we're going to validate a molecule here. And let's pass, so if I do a normal one, H2O1, everything is fine. But if I give it an extra A here, yeah, invalid molecule format. Okay. So that sounds good to me. So we've handled one possibility, is a lowercase a is just in the wrong spot. Now let's try an extra hyphen. So if a hyphen is in the correct position, that means that there should be a upper or lowercase letter before it and a number immediately after it. And that's the only valid way that you can have things. So else if molecule I is hyphen and molecule I minus 1 So we need to check for something being a number and something being a letter. So for something to be a letter, does C++ have something for that? Let me see. Is alpha, the internet seems to say might be valid. Let's find out if that's actually the case. I'll try to compile it before I go too much further. So is alpha molecule I minus 1? If the previous thing is an alphanumeric, not alphanumeric, alphabetic. Or if it's not that. Yeah, okay, so that seems valid. So if that's the case, then if I put in something with 2 hyphens, so this should be valid, or hold up, no, that should be right. Okay, something is messy here. Oh, because it could be a number too. It could be a number or a letter, so. Is alnum this one? Is that better? Okay, there we go. However, if I put in 2 hyphens, now it's angry. Okay, so is alnum built into C++? You never really are going to memorize all these kinds of functions, but I just did a quick lookup just to see what function that's there. So if there's a hyphen and the previous symbol is not a alphanumeric, then I have an issue. There's another possible issue I could have, which is, or the following one might not be a alphanumeric. Molecule I plus 1. The reason that this is important is because, oh, did I miss a parentheses? I did. So many parentheses, it's hard to keep track. There we go. Okay. The reason for this is that I want to be able to catch errors like this one, but I also want to catch errors like this one, where that's a problem. If I don't include this second part of the comparison here, where I check to make sure the next letter is alphanumeric, I might end up in a scenario where it ends with a hyphen, which isn't quite right. So this is my hyphen issues. Now I need an extra number. So else if molecule I is a number, and I think this is where I have to do, oh, is there an is digit? Is that a thing? Let's try is digit. If it's a digit, and so the previous and subsequent characters need to both be hyphens, or this whole thing is kaput. In fact, not only that, but, or actually, I guess that should be okay. Well, I need to make sure I account for scenarios where somebody puts a hyphen, a number, and just like does that a whole bunch. So it should be the case that there is a hyphen on either side, but the hyphens I don't really have to worry too much about. I don't know, I should verify that it's exactly correct. So if I've encountered a number, then 100% it has to be the case that there is a dash before, and then before that is a letter. So if it's a number and there isn't a dash before, so not molecule I minus 1 is a hyphen. So that's one that's one problem. Another problem I could have is the symbol before that not being a letter. Not is alpha molecule I minus 2. You could have a number with nothing after it. That's a possibility. but I can't have a number that doesn't have a letter 2 spaces before it in this format. And I'll throw my error. Oh, did I miss another? Always missing brackets and braces and things. I think it's a parentheses here. Yep. Okay, so now what this will catch. So again, the normal ones should work totally okay. S5 if I feel like it. What this should catch now is if I have something like this, 5, 5, that's not valid. I can't just have a bunch of numbers in sequence. And then lastly, missing number. So if I have a letter, else if is alpha molecule I. So it's a letter, and so then I have two possibilities. So first of all, it could be that it is a lowercase letter and there's a hyphen right after. So here's what I'm going to do. I'm going to say, given a letter, if the symbol after it is a hyphen, then the following symbol must be a number. So if it's alpha and molecule I plus 1 is hyphen, and it's the following one after that isn't a digit. So not is digit molecule I plus 2, then I have an error. There's a lot of errors that are possibly happening here. But let's see if that works. So, okay, so the thing I'm trying to correct for is what happens if I have just a letter at the end, like this. Okay, so it didn't quite work. Because actually every letter needs to either be lowercase, or it needs to either be followed by a lowercase letter, or it needs to be followed by a hyphen. So this is one thing. This will catch scenarios like the following, where I have like a dash at the end. So it did that at least. But I want to handle. So if it's a letter, or actually, let's say if it's upper. So is upper molecule I, and molecule I plus 1 is lower, so I got a uppercase letter and then a lowercase letter, then there must be a hyphen and there must be a number. So we'll do that kind of in this block actually. So I got uppercase and lowercase. If molecule I plus 2 is not equal to hyphen, then I got my error. If molecule I plus 3 isn't a digit, I also have an error. Yeah, I mean, I guess that's actually everything, right? Oh, I guess the last thing is I don't want it to end with an uppercase. If I is molecule dot length minus 1 and is upper molecule I Actually, here's what I want to do. That's not what I'm looking for. What I'm looking for is to make sure that if it's not followed by a lowercase letter, it must be followed by a hyphen and a number. So else if it is upper, and then kind of the same thing here, just +1 instead of +2 and 3. A lot of different errors we could run into here. Okay, but now this should be detected. Okay, so let's go through all of them. So this one is a lowercase letter without a preceding uppercase letter. This one is a hyphen which doesn't have a number / letter on the sides of it. This is a number not preceded by a hyphen or a number not preceded by a letter 2 spaces before. And this is a letter not followed, or hold up, yeah, not followed by a number. An atom with 2 letters not followed by hyphen number. Oops, spell atom correctly. And then finally, an atom with 1 letter not followed by a hyphen or number. There may even be other things that have crossed my mind here, but the kind of important part is being able to throw these errors appropriately and validate them all in a function, because I think if I had to write all of this in the code down here, it would get even longer than it is before. In fact, one option is even I could put all this in a different file if I wanted to, just for the sake of validating things, which isn't the worst idea. Maybe I'll actually do that, and I'll say validate molecule.cpp. And I'm going to actually copy this function there. We'll put these in on top, just so that they're there as well. Whoops, not what I meant to do. So that's there, and then this will include validate molecule.cpp. And it's still fine. So this is nice just because my main function is already taking up a lot of this code. There probably are cleaner ways to shorten this for sure. But I kind of just like went at it without really considering, are there ways I could maybe optimize this code a little bit? There is a fair amount of what was I saying? Lost my train of thought. There's a fair amount of repeated code, I should say. When I print kind of the same way every time. And over here, since this is a whole bunch of code that's only really relevant for validating the module, let's just put it into its own file, and I can import that file over here when I include it, rather than messing everything up into one giant spot. And if I have to fix the validate molecule thing, I can do that in its file without having to tinker with this exercise. Okay, so that's it for that. And I think I may pick up exercise 5 in the next time I set up to record, but it'll be part of this video. So I'll see you, you'll see me in a few seconds, but I'll see you in a little bit. All right, take care. Okay, let's continue our exercises with exercise 5. So here we're going to start with some new files. And in this new program, we're going to make 2 classes, one called element and one called compound. Element should have some member variables, symbol, and atomic number. Compound should have a vector of elements, which kind of makes sense. and write a makefile for compiling these classes and a main function. Okay, so let's go ahead and do that. And we're going to make a brand new exercise for this. So this is exercise 5. Here's what it says we need. Element and compound. And our elements are comprised of some, or our compounds are comprised of some number of elements. So that makes sense to have a vector in them. Probably what we'll do is, to make sure that this works okay, we'll also get some output. We'll see if we can make some maybe some display functions that show what the element is and what the compound contains. And something to keep in mind is that if we are putting a if we have a vector of element objects, we want to make sure that we're reading everything in the right order. So, okay, so let's start with element, because that seems pretty simple. Class element. What is an element? It's going to have a string symbol, and I guess if I want to include string, I need IOStream, and I need namespace std. And I got an atomic number. Probably should format this a little better, such as that. Okay, and then I think publicly what we'll just do is we'll have a constructor, one that's empty. We'll have another element constructor which takes a string symbol and an int atomic number and assigns those to our variables, symbol S, atomic number A. And we'll have a display. So void display, and it will output this element is the symbol with atomic number. Sounds fine to me. Now, we're going to have a main function, but the main function we're going to actually keep separate from this one. So the other thing we do need, though, is our compound. So compound. And here we will privately have a vector of elements called composition. Publicly, we will have our compound constructor, which doesn't really do anything. We will have a void function add element, which takes an element and pushes it back into our composition. This way we can add stuff to our compound. We don't want to really have a constructor, because with a constructor, if we wanted to build a compound, we'd have to already have the vector in place, and that's kind of messy. I would rather just make an empty compound and then put every element into it. Now, something also to keep in mind is that we're going to assume, and I guess we'll write this here, assume all elements of the same kind are in order. This is important because if, for instance, our compound is NaCl2, something like that, our vector should contain one element Na, another element Cl, and another element Cl. And we need to make sure that when we display this, it shows the correct information. And maybe our display should actually look like, I guess this is fine. But what I think we might want to do with our compound is make it display like those other exercises did. And so for that, here's what we're going to do. We'll also have a display for compounds, but it's going to work a little differently. So let's think about how this is going to work. The idea should be that for every element, for every unique element in my composition, I want to print it, and then print out how many there are. Sorry. So first of all, I need an element count, which starts as 1. Now I want to iterate through all of the elements of my composition. I can do this, I think, with the shorthand for going through a vector, but sure. So this should work then. Element E in composition. if it doesn't work, I can always go back. So for each element in the composition, and I guess here I need a public function to get the symbol. So I will have string get symbol, symbol, return the symbol, because I'm going to need to be able to retrieve that. And we will have, so I'm just thinking a bit about how to solve this problem. So here's what we want to make sure that we handle. When we have our vector and we have a whole bunch of elements all in order, we don't know if we have reached the final element of the series of elements that are all together. So if I have, what's the difference between NaCl2 and NaCl3? Well, there's an extra Cl3. But when I've hit the second Cl, how do I know that that's the last one or not? I don't really know until I've gone to the next one that's there. So here's what I want to do, is I want to, first of all, if I haven't gotten any elements yet, then the first one I run into should be my very first element I have to worry about. So we're going to start with string current element is empty. Okay. Now, and so if the current element, actually I don't want it to be empty, I want it to be the first element of my composition, assuming there is one. So I guess first of all, if composition.size is 0, then I just return. There's nothing to do here. I guess actually what I can do is if not this, then I will do everything that's here. Yeah. If it is 0, I just won't do anything. But assuming there are some elements, okay, we're going to start by looking at the first one. So the current element will be the very first element. So that's going to be composition 0 dot get symbol. And we'll actually start with 0 of them. And now here's the two possibilities. For every element we run into, either it's the same as the one before, in which case we increment how many elements we've counted, or it's different from the one before, in which case we should print out how many we've run into of the previous one, and now update the new current element to be one of this one, and then keep going. So here's what that looks like. If e.getSymbol is the current element count plus plus. If when looking at a bunch of CLs and we find another one, we just add there's another CL that we've run into. But if we are NaClH or something like that, and we've gone through 5 CLs, and now we hit an H. Now we want to print out CL:5, the same way that our previous exercise did. So otherwise, we want to print out our result from before. So cout current element element count. And now the new current element is e.getSymbol. It's the one that we just ran into, and the element count becomes 1. Once we finished our loop, we have not printed out the very last element, so we need to do that. So we will do this part again. And that should display all of the elements in our compound. Let's compile this to make sure that we didn't make any blatant errors before we move on. G++, and I'm going to use -C, which means I just want to build the object. I don't want to actually make an executable because I don't have a main function. But I do want to make sure that exercise 5 actually builds correctly. And what did I mess up? Vector does not name a type, and that's because I forgot to include the vector library. So I will do that. Vector. Try that again. Okay, so as far as I can tell, everything is okay. Also, if you look at my directory, you'll notice that now there is an exercise 5.0. This is actually pretty important. What this is the object file that was built from the C++ file. It's basically the kinds of instructions that are run based on the classes and functions I've defined here. But there isn't an executable. You can't run this. Nothing would happen. There's no commands to actually go through. So I want a separate main function, and I'm going to call this... I suppose we'll make it main.cpp to be, or we'll make it main5, just to be unique. main5.cpp. And here is our actual main function. What is our actual main function going to do? It's going to take these classes that are here. And so for this, I'm going to, let's see here. How do I want to do this? So I probably should actually split this up a little better. Right now, it's not really split up. It's like everything is kind of dumped into one CPP file. But I think what I want to do is actually distribute this between some header files and a CPP file that has the actual code. So here's what we'll do. We'll have exercise 5.cpp, and we'll also have exercise 5.h. Exercise 5.h is just going to have declarations. It won't actually have any of the code. And what it will have is some extra stuff I'm going to put at the top. If not defined, I guess this is actually kind of review from the modular programming content. But I think I want to do something like that because this is a good indication for that. And this is element, define element. At the bottom we will end if. And then in here, let's remove the code. So here the code, I think I want to remove this. I want to remove this. And that goes there. Actually, I think it's like this. See, compound, add element, display, and that should be fine. Then our exercise 5.cpp is going to include exercise 5.h. And now I don't need to declare these classes. Instead, I can just go with oh, I forgot to remove this. There we go. So now there should be no code here. Everything should just be declarations in my header file. And my CPP file is going to have the actual code and none of the declarations. So I don't need any of this. I do need the element constructor, both of them. The element get symbol, the element display. There we go. So the compound class is already declared, so now I need the compound methods. So there's this one, there is compound, add elements, there's compound display. Tab this back and take this little bit out. Okay, so I didn't do too much there except to basically separate some of the content here so that the CPP file has this code, the header has these declarations, the CPP file includes the header, and then finally my main function is also going to include this header. So now I can go include exercise 5.h int main. So I want to build an element E, and we'll do NA. I forgot that the atomic, that's sodium, right? Sodium is that 3? I'm probably very wrong, but pardon my inexperience with chemistry. It's been quite a while. Is this 9? I'm just guessing here, and this is E2. Okay, so I want to make sure that NaCl4, for instance, will work okay as a compound. So compound C, C.add element E, and then add E2 4 times. And if this worked correctly, I should be able to do C.display. So now my main function looks nice and short, which is cool. I just have the elements, the compound, adding everything to it, and displaying. All the actual code is over here. Now, I have to build all this, and once you start getting into the point where you have all these files, building them like with writing all the statements that go into G++ takes a long time. So there's a shortcut, which is called a Makefile. So we're going to write a Makefile that compiles these classes and a main function. Now, to make our Makefile, you can either use a code editor in here, such as Nano, which will let you create a Makefile. This is, I think, something that's more comfortable for anybody who's used to working at the command line. I wouldn't recommend it if you're very used to using a graphical user interface. But if you do decide to use the graphic version, first of all, you must call it Makefile. If you call it anything else, it's not going to work with no extension. The Makefile also operates on, kind of like Python requires you to have specific spacing, Makefile requires you to use tabs. So in order for that to work, I actually need to go to my settings in Jupyter and change the text editor indentation to indent with tab. If you don't, it won't quite work correctly. So you can see in my header that my tabs are just empty space. In my Makefile, they need to be the special tab that's here, or it won't be able to read things correctly. Now, what is it going to read? Well, the way that a Makefile is set up is it requires targets and dependencies. So I need to specify what are all the things I want to build and what are all the things that need to be there for it to be built. And for this one, what I'm looking for is I want my goal is to build an executable, right? And the executable I'm going to build, I guess we're going to say, what should I name it? This will just say exercise 5, right? Now, what do I need for exercise 5 to be built? I need to have an object file from exercise 5 CPP, and I need an object file from main5.cpp. So main5.o and exercise 5.o are required for this to work. If I have those object files, then I can go g++-o exercise 5 main5.o exercise 5.o. Now what if I don't have those object files? I need to build those. So how do I build main5.o? Well, I need main5.cpp, which requires what was I saying? G++ -c main5.cpp. And here I'm just building the object file for main5. And then similarly for exercise 5, exercise 5.o, I need exercise 5.cpp, so I need to compile that. Okay, and I believe this should work, and we'll give it a shot, and if it doesn't, we will reconstruct the things that we need here. But I think that should be good. Okay, so if I type make, you can see actually what happens is it writes out all the commands that it is running for me. So when you type make, what happens? Well, if there's a file called Makefile in your directory, it will go in there and it'll look for the very first thing, which in this case is build exercise 5. Okay, how do I do that? Well, I need to have main5.o and exercise 5.o. I didn't, so it goes and needs to build those things, which in this case means make the object file for main5, make the object file for exercise 5, and then build my thing. Now, once those are there, then it can run, compile the whole program, and now I can do exercise 5, and I get my NA1CL4. It looks like I'm missing a space here, or I should actually have a comma space. So let's actually fix that. And to fix that, I need to modify my display here. So after the element count, oh, and this is where I want to kind of go back to how I did things with exercise 4, which is I need to track if it was the first element or not, so I know whether or not I want to print a comma. So the way I did this previously was, where was it? I have a Boolean called isFirstAtom. which is true. And you can see here I have now the tabs are sticking around. You can turn these off if you want to. So anytime that you're working with a CPP file, you can go back to using the spaces if you prefer. Oops. There we go. And then when I output, if it's the first atom, then now it's not. Otherwise, I want to print that that comma. Oh, and that should go before I print out the element. This is just for formatting more than anything else, but I do want to make it look nice and readable. So if it is not the first atom and I'm printing it out, I want to print out a comma space, and then it'll print out the element. And when I hit the last one, it won't have a comma after it. Now, let's make this again. So I just type make. Now, what do you notice when you look at what's been run here? The main function never got re-edited. So I noticed my mistake. I fixed it in exercise 5.cpp, and here's kind of the, I guess, quote-unquote magic of make. It saw that there already was an object file for main5. So since there is, it doesn't need to build it again. I can save on my time by not compiling code that I already know is already done and hasn't changed whatsoever. But exercise 5 did change, which means I need to rebuild my executable, but I only need to compile exercise 5 code before I can then assemble all the object files. So anytime that you run it into a program where you have a ton of files and you only need to change one little thing, rather than then requiring you to rebuild every single file in your system, Make will ensure that the only things that are being rebuilt are the ones that need to be. Now I run exercise 5, it didn't seem to fix, so that's not ideal. Okay, what did I think I must have messed up the logic here. Let's go through this. Let's print out a test code to make sure that this is working correctly. Make, run. Okay, so it is working correctly. It's just that there is an error in my logic somewhere, and I have to figure out what that is. Probably another thing I can consider also is instead of tapping up repeatedly to go /exercise5, I can actually add that to my Makefile. So one of the targets I can have can be something called run, and it requires exercise 5. And if I have exercise 5, you can do /exercise5. And the cool thing about this is now I don't have to do /exercise5 all the time. I can just say make run, which I happen to be faster at typing. Maybe it's different for you, but this might save me a little bit of time in the future. So, okay, so there is a logic issue here because it's not printing out my commas even though I want it to. So, NaCl. The first time I go through, there is the first atom. So when I print the first atom, it should print a comma. It should just print the element and the colon. Okay, but when it gets to Cl, oh, I see. So here actually it should have the same thing. There we go. And here I can see the all of the tabs using the Makefile format. This won't affect the CPP file. This will actually run okay, but that's fine. So now I can go make run. And look at that. So make run, because it requires the executable, will go and figure out what needs to be done for the executable, which is I need my executable file. That has to be updated because the CPP file has changed for exercise 5, so I have to compile that first. then I build the executable, then I run exercise 5, and now I get this. So I can just type make run, and make run will do everything I need to do to get this working, which is pretty awesome, I think. And it will be very convenient when you're working with even bigger programs. So before I move on to the next exercise, I am going to put all these into a single folder. Since Makefile must have a unique name, you can't have two Makefiles in the same directory for two different projects. You can only have a single Makefile. So I'm going to have a different folder. I already have a... Oh, sorry. Oh, I see, because there's an executable called exercise 5. So I can't have my folder also called exercise 5, which is probably not ideal. So let's call this exercise ex5. And then we'll put all of my things that we just did into there. Okay, and there it all is. All right, then we can move on to the next one. Okay, let's go on to our next exercise. So exercise 6. Modify your Makefile to use variables instead of being entirely hard-coded. Include variables for compiler, target, and object files. Also include a phony target called clean, which removes all object and target files. Okay, so we'll do the clean thingy after. Let's start with the first part. Modify my Makefile to use variables instead of being entirely hard-coded. So right now, everything is hard-coded without exception, and Makefile allows you to use variables. So we can replace a bunch of the repeated content here using those variables. So let's say, for instance, we want our compiler C something something. This is going to be G++. And so instead of me writing G++ everywhere, I can do $sign to indicate this is a variable, parentheses CXX. And now this means that if I want to use something other than G++, maybe I want to use GCC if I'm doing a C program or something, I don't need to rewrite the G++ everywhere. I can just change it in a single spot. We also want to change the target. So here we'll say target is going to be exercise 5. And so here again, I can just say target. And I think actually it's intended that these should all be all capitals for the case of making it very clear what's happening here. So here is my target. I got target here. Yep. And then my object files, objects, are going to be main5.o and also exercise5.o. I got multiple objects, and so I want to list each one of them here so that when I have, for instance, all of them here, I can just put in a single $obj. And now I also can put them over here as well, actually. I can replace this with objects, and I can replace this with target. And now I'm really shortening how much of this is actually hard-coded into my program, which is very nice. Now, I think I can't do much about these because this is where I have my actual main.cpp and so on. But that's okay. I think it's fine if we have this here. Now, just to make sure I didn't break anything, we're just going to do a make run and make sure it still works. So make run. I don't have a target for run. That doesn't seem quite right. Oh, because I'm in the wrong directory. Let's go into, and in fact, actually, I made a bit of a blunder in that I forgot to save my previous one. So let's go back before I made all these changes. Okay, so this was my old Makefile. Let's put everything in a new folder. This is exercise 6. We'll make a new Makefile, and we'll put the thing we just made here. And then let's copy all of our files over here. Paste. Okay, and here is where I will launch a new launcher. Make run, go. Hey, look at that, all is well. Obviously, since the CPP and the CPP files haven't changed, the object files haven't changed, nothing has changed. It just directly built my executable and gave me my code. So, hooray. Okay, now we also wanted it to make a phony target called clean. So how does that look? Well, first of all, I need to declare that I'm going to have a phony target called clean. What does a phony target mean? Basically, anytime that make is going to build something, whether it's exercise 5.0 or my exercise 5 executable or so on, how does it really work? Well, what it's doing is it's looking to see, does this file exist? If there is a file already called exercise 5 and it's up to date, I don't need to update it or anything, it just won't do anything. It'll just say, oh, okay, we're good to go, right? I think if I do, you'll see, yeah, if I do make run a second time, so the first time that I did it, it was kind of a new file because I put everything in a new directory, so I had to rebuild the executable. But now when I make run again, you'll see it didn't even compile anything. It just ran the executable. It's already there, so it doesn't need to do anything except for run. But how does it know that? Well, it looks at all of these targets and says, hey, for each of these targets, are any of them out of date, or any of them new, or not new, or any of them old and need to be updated? If the file isn't there, like if I delete exercise 5, for instance, so it's rm exercise 5, right? I do make run. You see, it will immediately build it again because it says, oh, your executable is missing. We need to give it back to you. Right? Same thing if I do rm main5.0 and delete this object file and then do make run. So the first thing it does is it rebuilds that object file, then it links everything together to make my executable, and then it runs the program. Now, with my clean, so what is clean? I want to write a command called clean, and the point of clean is not to have any dependencies. All it's going to do is delete these extra files. So we're going to remove the target and the object files. Because sometimes you just want to like redo everything from the beginning, right? I want to rebuild it all from scratch, so to say. So I can say make clean, and it deletes all the stuff that's there. And then I can say make run, and it compiles, builds, links, good to go again. A fresh run, a fresh build. The reason to do this is that sometimes you have a file called clean. And then the computer gets confused and says, oh, I don't need to clear up your directory. There's already a file called clean, so I don't need to run this code. And that's not quite what you're looking for here, right? It's possible you may actually want to include run as well as also being phony. But this is sort of just a secret, like a special keyword for make to realize that, oh, clean and I guess run as well are not actually intended to be the names of files. They're just commands that I want to do. Sometimes you can even say all at the top, which is also another one that's commonly put in here, all. And for this one, I'm usually going to look for the target. If the target is there, then I will execute everything. So now I can do make clean, make all. It'll run everything, just kind of like make run does right now. There's not really any difference here, but sometimes it's the case that you want run to only, for instance, run an executable. And sometimes you want all to do other things. But in any case, it doesn't really matter. The only thing that does really matter somewhat is actually whatever you put first is what runs when you just type the word make in. So if I do another clean and I just type make, it will do make all because I put all first. And right now, all and run are kind of identical, but you may want to have some variation between these. Maybe it's the case that when you run, you only build certain things and run them, but here they're identical because this program is so small, there's not too much difference. So, okay, so that was it for this exercise. On to the next one. Okay. Modify the Makefile to accept at least one command line option. For instance, using a target called debug, allow the user to compile a main program with the D flag, which runs print statements scattered through the main function. Okay, so not too hard to do. So here's what we'll do. First of all, we're going to, can I duplicate the directory? I don't think so. No, I can't. So I'm going to have to copy everything in here. Copy. Make new folder, exercise 7. Exercise 7, I'll dump everything in again. And now we want some command line arguments. And in particular, these ones are called flags. So we're going to have our C something something flags. In this case, we're going to have D for debug. And now what I can do is I can actually have my all, yeah, we'll have my all be the one that uses this flag, so it'll be $C flags, and my run will not include it. And again, you can decide if you want that to be the case one or the other. But here, when I run my executable, it'll say exercise 5 -D, and when I do run, it will just do the normal version. And now, what is the significance of having this -D? Well, now if I go to my main code, I can take args C, character array arg v, and I can say, so now I need to include string as well. I might not need to have these, but I'll put them in anyway just in case. Yeah, we'll do it like that. Okay, now if arg C is equal to 2, if arg v 1, and so we're going to need our flag. Flag equals arg v1. Or sorry, not arg v1, is D. If this is the flag, then, and we're going to need a variable called, well, I guess we'll call it debug. So bool debug equals false. Otherwise, debug is true. Sorry about all the tabs. I just keep forgetting to turn off the tab thing, but I think it's okay. All right, so now I have a setting which says whether or not debug mode is on. Right now, debug mode doesn't do anything, but let's make it do something. So we'll output. So if debug I don't need any braces because it's going to be very just like one line. If debug output creating sodium null. We're just going to add a whole bunch of debug statements around here. So we'll have a debug statement here. Put one here. I don't want it to keep... Actually, I can do this in one line, just like this. Maybe that'll make it a little cleaner. Debug here and here. There we go. Just going to throw in a whole ton of debug statements. Creating sodium, creating chlorine, creating compound, adding sodium to compound, adding chlorine to compound, same thing here, same thing here, same thing here, displaying compound. Okay, so now I got all this debug code, which basically prints out a whole bunch of extra stuff, provided I run it with the D flag. Now when I go to run it, so I can do make. Oh, look at that, everything shows up. All my creating things, adding things, and displaying it, and so on. And if I do make run, it will only just run it. It won't do the whole thing where it displays all the stuff from the flag. And this is a lot more convenient than me having to tap up all the time to get to my previous command, figure out, oh, when's the last time I compiled this? You know, Makefile, although it's kind of tedious to build it, it will overall save you more time. And a really good thing that you can consider doing sometimes is actually just copying the format and then just modifying, for instance, the object files that you're dealing with, rather than having to make a brand new Makefile every time. So I encourage you, copy Makefiles. They will save you some effort. Okay, on to the final one. Okay. Modify my code from exercise 4 to use the element and compound classes. Build this new program with a Makefile. Okay, so we have a whole bunch of stuff here. And I think we want to take advantage of the fact that we have a bunch of these things. I'm going to copy this. I'm going to make exercise 8. I'm going to dump everything in here. And now what we are going to change, though, is our our main file. So right now our main file does all this debugging stuff, and this is just here to get things to work. But what I want to do is run our program from exercise 4, where we got the molecules and everything from the command line. So this means we'll have to change our Makefile quite a bit, but I think that's okay. So first of all, over here, here's my main. And dump everything in here. I need the validate molecule code as well, so I'm going to grab that. Copy. Okay, so what do I need to do to fix this? First of all, the whole point of having these element and compound classes is right now all my code does is display things. But I can take advantage of, first of all, I know how to display stuff. It's in my compound class, so I can just build the compounds and then I have it all done. And then second of all, I can, once that's actually there, I could potentially do other stuff after. Because right now, all that my program really does is it just plays it back. But maybe later down the line, I want to, add this to a file or something like that. And being able to store it in a class can make that a lot more convenient. So right now, I'll get rid of some of the comments here that aren't really necessary. I have this set up so that it takes things in different formats. So I'm going to have a few different make options for running this so I can do the different formats. And I'm going to use the code I wrote for exercise 5, which has these classes in here, so that I can take advantage of those classes. So we're going to include exercise 5.h. So now I have an element class and a compound class. So that's kind of handy. Okay, let's go through here and see how much we can simplify this. So we do need an S flag. This is the flag for whether it's simple or not. And we're going to have to definitely change our Makefile for this. So our flag here is S instead of D, because we don't have that. So this was main 5. We're going to make this main 8 now because we are on exercise 8. But I'll leave exercise 5 there because I don't want to really change that code if I don't have to. So here it's main 8, main 8, main 8. We don't have to change too much there. And now I have all, which I guess we'll have that do the simple one. And in this case, let's have this do, just for the sake of testing, let's have a couple of different options. So the simple version, I think, was where we can do Na2Cl4HMG5. It's like a really wacky looking molecule. It's probably not a real thing, but it has the format that should be proper. And then I think, what was the other format that we were dealing with? This was the one where everything's followed by hyphens, I think. Yeah, so for this one, we'll do something like, MG4NA1S104, something like that. Just to have some test cases here. Okay, so that's good enough, I think, for my Makefile. I don't really need to do much else here, but what I do want to do is modify this so it uses my classes, because right now I'm not really using them, and that's kind of wasteful. So let's look at this one. How can I do that? So right now, my molecule is just a string that I grabbed from the vector. I validate that it's in the right format, and then assuming it's in the right format, I start to put everything together. So let's see. We get the atom if there is a current atom. Otherwise, oh, I see. We get, we get an atom. And if we have an atom, then we figure out how many there are and we print it. Okay. So what we'll do in addition to, or instead of printing things out here, we'll build our molecules and then our compounds, and then we'll print them out after. Because we already have a thing for printing. We don't have to use all the stuff that's here. So I can ignore all the printing stuff because that's not really relevant anymore. I just need to figure out what is the contents of the compound, and I can put it into my compound. So okay, so if I'm at this point here, I now let's actually disable the tab thing for the sake of making this look a little nicer. If we're at the point where we know how many there are, So we're going to get the m count and create compound. Now, right now I want to, or sorry, not create compound, and add to compound. So we're going to actually build the compound. Remember, this is this whole thing is just to build one compound. So we're going to make a compound C. Well, actually, we'll call it compound with lowercase. Okay, so here's my compound, and I'm going to build it, and that means that we need to use my add elements to the compound. And then when I'm done, at the very end, I will actually do compound.display and use that function that I built in my exercise 5 over here, this one that displays the compound. So all I have to do instead of writing all of the code to display stuff in here and print all this stuff out, you know, blah, 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 print, and who cares? This isn't relevant. All I need to do now, I'm just going to keep deleting all of the extra printing stuff here. This is shortening the code quite a bit. Delete this printing, because I can already print, I already wrote code to print, so I don't have to worry about that. Add to compound. What I'm going to do is I'm going to build the compound up by adding all the elements that need to be in it, and then once I've completed going through the whole thing, I will just display. I'm done. Okay, so how do we build this compound? Well, in the simple version, we get an atom, and then we get the atom count, and then we add it to the compound. So for I is 0, I is less than, what is I less than? The current atom count, I plus plus. Compound dot add element, current atom is the name of it. And it needs an atomic number. We didn't figure out how to get the atomic numbers, so we're just going to put in a 0, which is fine. But this will now add in an element for each one that was in the string. So that's actually it, which is kind of nice. Let's shorten the code here quite a bit. And then over here, kind of the same thing, where I have all the code here for figuring out an atom, and then when I'm at the point where I'm going to print it, or at least add it to the element. So let's look at our scenarios. If we run a new atom, great. If we find the number of them, we want to add that number to the compound. So it's this number. So we're going to add that many to the compound. Great. And then finally, I want to add the current element if we encountered a new atom but no number. So there we go. So this shortened the code quite a bit, which is really, I think, what I was mostly looking for here. Rather than having all that messy print statement stuff, it's all built into the compound. And if I did this correctly, it should just work right away. Let's find out. Okay, I'm in the wrong folder. So let's go into exercise 8 and make go. Oh, what did I mess up? Oh, it's trying to make the... Is that right? Main5.cpp. Did I leave an extra make? Oh, here it is. This should have been an 8. That's what I messed up. Missed that one. Okay. Let's try that again. Make. Oh, we got some errors in here. In line 35 of my main, I have, I've been using capital C for compound, but it should be lowercase c, because capital C compound is the name of the class, lowercase c is my current compound. Let's try that again. Clear, make. Okay, so Na2Cl4HMG5 is Na2Cl4H1MG5. Looks good to me. How about make run? MG4 Na1S1O4, and there we go. And so in no time at all, really, it didn't take me that much time to modify my main function to use these new classes. And now the benefit is, here I'm just displaying it, but you can imagine that maybe it's the case that once I read in this compound, I want to do some other stuff. If you want to practice a little bit more with this, one thing you could consider is taking all of this code, because this is also like a big long chunk of code. First of all, split it up, because right now this is just two different versions of the program being run based on whether the S flag is set. Put all of this into one function, I think, to clean it up a bit. And same thing for here. And you might want to separate those into different files. Put those in your Makefile, make sure all that works. And then if you really want to go another step further, what you can actually do is you can use your Makefile to pass in another file, and maybe that file can have a whole bunch of different compounds and run this program and all those things. Something a little bit more useful, hopefully. But that's it for this exercise, and I will see you in the next one.